Here we have four small identical circles inside of a large circle, and we ask to find this blue area between the small circles. Each of those small circles is tangent to two other small circles and also tangent to the large circle. All we know is the radius of the large circle, which is big letter R. Apparently the author of this problem decided to make this problem a little bit harder. He decided that he doesn't want to give a specific number and wants you to get an answer as a formula. Let's call the radius of a small circle a small letter R. And now consider the shape we're going to get if we connect points A, B, C, and D. That's going to be a square, and the side of a square will be equal to two small r's. Notice that blue area equals to the area of this square, ABCD, minus those red areas. The small area consists of four congruent parts, and each part is a quarter of a small circle. So 4 quarter of a circles means one small circle. So blue area equals to the area of the square, which is 2r squared, minus area of a small circle, which is pi r squared. And that gives us this formula that relates the blue area with the radius of a small circle. We're going to draw a diagonal of the square, dB, and we can actually extend this diagonal until it intersects the circles. We get a point E, which is a point that belongs to this diagonal or extension of the diagonal, and the large circle and one of the small circles. And now notice that we have OE, which is big radius, or radius of a big circle, that equals to OB plus BE. And BE is the radius of a small circle. So we get this relationship between big large circle and a small circle. Now all we need to do is to find this OB. Notice that OB is a half of diagonal of this square dB. And dB could be found from triangle ABD. That's a right triangle. dB is the hypotenuse. And we know what AD and AB are. They're 2R. So that gives us the answer how to relate dB to the radius of a small circle. Now we know that OB is half of this. And now we can plug this OB into this formula. And we get a relationship between big R and a small r. Here we can express small r via big R and substitute in the formula for the blue area here. And we get our final answer.